Alright, how you guys doing today? This is Mr. Muscarella coming at you, and we are going to take a look at determining the equation for an ellipse. Now there are two different equations, and what I want you to do is pay attention to where the a squared number is. Where that variable is, or where numbers will be when we actually plug in some numbers, that spot is going to determine which shape the ellipse has. So that's something that's really key that we're going to have to pay attention to. More on that in a little bit. First, we're going to take a look at the one where your a squared is bigger underneath where the a squared is going to be underneath here. Now, when we take a look at this, most of this is going to be kind of similar to some things you've probably already seen. Center is going to be at HK. So center, that's not going to be too difficult to figure out. But your foci and vertices, remember by their definitions, they are on the major axis. So your foci is going to be a little bit to the left and a little bit to the right of your center. And the center is actually halfway in between your foci. Now the vertices, they're on the edge of the major axis, so they're going to be all the way out here like that. Now the major axis, here's a small thing that I want you to pay attention to, but the major axis for this one is going to go through all of those points, and it's going to be parallel to the x-axis. So you'll be able to get this pretty soon, and once you get all this stuff, it's going to make you really happy. Now with this, there's a couple of things to pay attention to. Of course, A and B both have to be positive, and they have to be in a particular order because A's got to be bigger than B. Now sometimes we're going to have to figure out what the b squared value is, and there's two different equations to help you do that. Now let's take a look at our other equation for the ellipse. For this one, when we take a look at it this time, when you look at the bottom of a fraction of the two fractions, the bigger number is going to be underneath the y term. So this is going to be slightly different in some ways, but generally it'll be the same idea. So our center will still be right here in the middle of our ellipse, but then where our foci are, now this time our foci are going to be a little bit different because they're going to go a little bit above and a little bit below where our center is. And again, the center is halfway in between where the foci are. But then your vertices, again, so they're going to be below and above the center, and the line, that would be the major axis, because that's going to be containing both the center, the foci, and the vertices. The major axis, in this case, is parallel to the y-axis. So again, same equations and same kind of requirements, with A having to be the biggest number between A and B, and two equations to help you find the value of b squared. Alright, so we'll practice these and it'll start to make sense when we actually put some numbers in, but I wanted to go ahead and show you one page that kind of summarizes all of that. So this page is the one that kind of puts everything together, and it's all right there in one spot. Alright, so here we go with this example where it says find the equation of an ellipse with center 0, 0, focus -1, 0, and vertex -3, 0. So what I do first is I start plotting stuff. So my center is right here, so that's cool. Now my focus is at -1, 0. So I'm going to go -1 right there, -1, 0. Now the focus, remember, that's halfway in between, or the center is halfway in between my foci. So if I have one that's one on the left side of the center, then I'm going to have my other foci is going to be on the right side. So there's both of my foci right there. And then I'm going to look at the vertex, and the vertex they're saying is at -3, 0. So -3, 0 is right out there. And again, this is kind of symmetrical. So if it's 3 to the left of the center, then I'm going to go 3 to the right of the center and plot my other vertex. Now, what this just kind of tells me is, real quickly, generally the shape of my ellipse is going to be one that goes like this. So that's going to help me out with a couple of things. Now what I'm going to do is start to put together the equation. Now I know for the HK part, that is coming from the center. Now generally we have x minus h squared plus y minus k squared. And that's going to be over stuff and everything, but if h and k are both 0, then that means I'm just going to have x squared and plus y squared. Now my ellipse is set equal to 1. Now I don't know what's in the denominator yet, but we're going to figure that out real quickly. Check this out. So I know my ellipse is shaped like this. It's going to be a left-right one, which means my a squared value, the bigger value, is going to go underneath the x squared term. Now to figure that out, you're going to have to be able to do this really complex math thing, and that's called counting. So what I'm going to do here is I'm going to actually count the distance from the center to one of my vertices. So I'm going to count that whole distance right there, and that distance is 1, 2, 3. So that distance is 3. Now when I square 3, I get a value of 9. So that means underneath the x squared term, I put a 9. So in order to find the b squared term, what I'm going to need to do is actually take a look at this piece right here. I'm going to need this. I need to find b, so I'm going to have to use b squared equals a squared minus c squared. Now, the c squared I actually can figure out because the focus, that is right here, c0. So my c value is -1. So if I square -1, I'll end up with 1. So -1 squared is just +1. My a squared value I know is 9. So I'm going to have b squared equals 9. And then my c squared value is 1, which when I do my subtracting, 9 minus 1 is 8. So that means my number underneath the y squared is 8. And again, don't forget, it's set equal to 1. So the equation for this ellipse that has a center at 0, 0, focus -1, 0, and a vertex at -3, 0 is x squared over 9 plus y squared over 8 equal to 1. Alright, so here we go for our second example. Now check this out. We've got to find an equation for ellipse with foci at 0 plus or minus 2 and a major axis that measures 8 units. So first let's plot our foci. So our foci are at 0, 2. So 0, 2 would be this spot, and 0, -2 would be down here. So both of those are my foci. Now remember, your center is actually halfway in between the foci, so that's kind of easy to figure out. If I just count, I can find that the center is right there. Now this is kind of leading me to a couple of things here, and we'll talk about that in a minute, but I know my center is 0, 0, which means that I can start to put together pieces of my equation for my ellipse. So instead of x minus h is just 0 and k is just 0, so I'm going to have x squared over stuff plus y squared over other stuff equals 1. I just don't know where the a squared term goes yet, or the b squared, but we'll figure that out in a minute. Now the second piece of information we're told is that this major axis measures 8 units. Now your major axis goes through the center and is also containing the foci. So check this out. If I know the major axis is 8, then the distance from the center to one end of the major axis is half of 8. So then that means that that distance is going to be 4. So from the center, I'm going to go 1, 2, 3, 4 up, and then 1, 2, 3, 4 down. So this is kind of telling me a little bit right here. Check this out. I'm kind of figuring out that my ellipse here is going to be one that's shaped like this. So if I have an ellipse that's shaped like that, that means my a squared term, that is going to go underneath my y squared. So let's figure out what that a squared term is. Now to figure out the a squared term, again, we're just going to do some basic arithmetic here and stuff. If I figure out this distance, we already did that, that was 4, so 4 squared, that just has a value of 16. So that tells me my a value is 16, and that's going to go underneath the y squared term. So I just got to figure out what the b squared is. Alright, so let me write my little formula here. So I'm going to have b squared equals a squared minus c squared. B squared, still don't know what it is yet, but a squared, I know that that has a value of 16. Now for c, remember your foci give you the value of c, and I know that one of my foci is at 0 plus 2 or 0 minus 2. So that means if I square that value, whether it's 2 or -2, either way I'll end up with 4. So c squared has a value of 4. So b squared is going to be 16 minus 4, and that's just 12. So that means I'm going to have a 12 going right up in there. Man, that wasn't so bad. So the equation of my ellipse is x squared over 12 plus y squared over 16 equals 1. Wow, we only have one more example to do, and then this video is wrapped up. Thanks for hanging in there. I know this has been a long one. So for this example, it says find the equation of the ellipse with foci at 1, 2, -3, 2, and the vertex at -4, 2. So first, let's go ahead and plot our foci. So I've got one at 1, 2 right up here, and another one at -3, 2. The center, don't forget, the center is halfway in between those. So if I find the middle of my foci, then I'm going to be right here at this point, -1, 2. So my center, this is kind of cool. So my center, that's going to be -1, 2, which means that I can start filling some pieces out. I'm going to have x plus 1 squared plus, and then y minus 2 squared, because remember we have to switch that. So our h is -1 and our k value is 2. So when we plug those in, that's what we got so far. Now I don't know what's in the denominators yet, but we'll figure that out soon. Next, I'm going to go ahead and plot my vertex, and my vertex is over at -4, 2. So -4, 2 is up here, and I'm going to go ahead and plot it on the other side also, because if I count that distance, 1, 2, 3, 4, or 1, 2, 3, I'm going to have 3 spaces in between, or 1 to the left of the green dot, which means I'm going to have 1 to the right of the green dot on the other side. So that's going to be where both of my vertices are. Now this is kind of cool because this is telling me that my ellipse is one that goes in this kind of shape, which means when I find the distance from the center to one of my vertices, 1, 2, 3, so that's 3. When I square 3, I get 9. Since I have a left-right ellipse, that means that a squared is going to go underneath the x plus 1 part. So a squared, that 9, is going to go right underneath there. Now to figure out the value of c, and I need to find b squared, so I got a little bit of work here to do. Now this is going to involve a little bit of work with our coordinates. So check this out. Now I've got 2 coordinates here for foci. Now I've got a general equation, so I'm going to write down one of my foci right here. I'm going to have 1, 2, and the other one that I have is -3, 2. So both of those are my foci. Now the general equation that involves c with our foci is this h plus or minus c. So I'm going to write that down for underneath both of these. Now since I am dealing with the x coordinate here, I'm going to pluck the x coordinate and just set this equal to that. And that's going to be equal to -3. Now the value of h, so I'm going to pluck that from the center. And I already know what that number is. So when I go ahead and plug in -1 for h, and then solve each one of those for the value of c, I get a value of 2 or -2, regardless of which x coordinate I use. So that's something to pay attention to. So it doesn't really matter which one you pick, as long as you plug pieces in the right spot. Now when I square 2 or -2, either way I come up with a value of 4. So that's going to help me out when I go to find my b squared, because that's a term I'm still trying to find. So b squared is going to be, remember that's just a squared minus c squared, and then the b squared is going to be my a squared term, that's 9, and I just found that c squared was 4, which means b squared has a value of 5. Booyah! We are done with this junk. So our equation for this ellipse would be the quantity x plus 1 squared over 9 plus the quantity of y minus 2 squared over 5 equals 1. Thanks for watching and hanging in there. I know this is a lot to digest, so you'll definitely need to practice this, and it's going to take a while for it to get into your brain and make sense the way it's supposed to. So that's all right. Take your time, you'll get it. But it is very tedious, and it's a lot of small little details. So hang in there, you'll get it, and I'll catch up with you guys pretty soon. You guys have a great day, and I'll see you around. Peace out.